Another reason that we might have NTP issues is that my router, my switch, my server, whatever device is learning time from my router, let's say on my network, that's providing time for my network. I've lost connectivity with that router. We could do a ping to see, can I ping the IP address of that router that's providing NTP to all of my network devices? And if I cannot, maybe I don't have an NTP problem, I've got some sort of other underlying network issue and I need to go troubleshoot that. Something else that could happen is that the server for my network, remember we might have a router pointing out to the internet, and we're pointing out to the internet to get time. And then we're feeding time out to devices in our network. We've got maybe a server, got a switch, we've got a router. What happens if some sort of connectivity issue happens between my NTP server and the NTP source on the internet? If we lose connectivity there for some reason, obviously the time is going to start to drift a little bit, and that could cause us to have incorrect or mismatched times on some of our devices. Another issue could be that the CPU utilization of our router is too high. The router has many different processes running at any one time, and under heavy CPU load, it simply might not have time to do all of its NTP chores. Here's how we can tell if our CPU is running particularly high. Again, we probably want to use some baseline information to see, is this a good number, is this a bad number? But let's do a show processes CPU command. And we can see on this router, let's reissue that command, we can see on this router my 1 minute average has been 3% processor utilization. The 5-minute average has been 3%. Wow, something's happened recently. We had a brief spike, it looks like. We were doing some process switching, it appears. But over 5 seconds on average, looks like we're using 5% processor. Now, I'm not going to be overly concerned with these numbers. Generally, I'm not going to be concerned with these numbers on a switch unless they get over... I'm not going to be concerned unless they exceed 10%. I'll start questioning it if it gets over 5%. On a router, I'm good with it being around 15% maybe as a maximum. Again, it depends on what your router's doing. It depends on what your baseline information is, but I'm pretty happy with these. But if the processor utilization is too high, just keep in mind that is a reason that NTP might not work. There's simply not enough processor cycles to go around to serve everything else the router has to do and for it to keep track of NTP. Something else that could be happening is that the initial clock of the router that we're configuring, and well, let me draw this up on the screen for you. Let's say that this is going to be our NTP server, and this is going to be our NTP client. And I'm trying to learn time from that server. If our initial times are way off, let's say the initial time, the initial delta, I'll say, the delta was maybe 23 days, and do something crazy like 23 days, 11 hours, and 12 minutes as an example. We're way off, bottom line. We are not agreeing on what time it is. If we do greatly disagree on time at the beginning, that client is not going to make the quantum leap to say, I'm going to go from my current time immediately to the NTP server's time. It's going to take cautious steps. It's going to say, I'll change my clock a little bit and a little bit and a little bit. It'll zero in. It'll get closer and closer, and finally it will synchronize. But if we have a big delta in our time to start with, that can cause an issue for us, no doubt about it. The fix for that, I should mention the fix, is simply go into that newly configured router, the router that wants to receive time, and using the clock set command, manually set the clock to something that's close to accurate, something that's close to the time of the NTP server. Another issue, and the final issue we'll talk about concerning NTP, is the stratum value is too high. Remember, much like RIP cannot route for a network that has a hop count of 16, we cannot have a device with a stratum level of 16 that's going to learn time. 15 is the maximum that will work. And remember, every router hop, every clock hop, if you will, we're going to change the stratum value. Let's say that we are learning from some cesium clock out on the internet. And let's say the cesium clock on the internet has a stratum level of 0. Well, if router R1 learns from that clock, it's going to have a stratum value of 1. It's going to be incremented. If R2 learns from R1, it's going to have a stratum value of 2. And on and on and on in increments. Now, by the way, rarely when you point out to the internet are you going to be contacting a device that has a stratum level of 0. 1 or 2 or 3 would be much more common of the publicly available NTP servers. But the point is, if we get to a point where a router would have a stratum value, let's say this is going to be router 16, R16, if it would have a stratum value of 16, that's not valid. In other words, if I'm trying to learn time from a router that has a stratum value of 15, I'm not going to be able to do that because that would give me a stratum value of 16, and that's too much.